Hogan had some other good ideas, a lot of points he brought up. When I was at University of Maryland, University College in Okinawa, Japan, I had to make a presentation on mantle plumes. It confused the hell out of me. Well, because I was a jarhead and I didn't know what the hell I was doing, but I still consider myself somewhat of a jarhead. Check it out, I can draw a perfect circle, look at that. Anyways, a mantle plume is a plume which comes up from the outer core and comes up to the crust like that. Okay? Of course, this is the Earth. All that energy from the inner core comes up through the plume, up into the surface, causing volcanic activity, obviously. Just like the Hawaii chain of islands. Okay? An important point I wanted to bring across was in my geology class, the professor wanted to push plate tectonics, meaning these plates were moving, supposedly. I consider that to be really strange because gravity only goes in one direction, down. So if anything, the plates weren't really moving because you have trillions of tons of material wanting to move downwards. All of it wanted to move downwards. So the idea of a subducting plate is what we call bogus nonsense. There are no subducting plates. The entire crust is wanting to move downwards. So that basically sums up plate tectonics in a nutshell. We can ignore it. But as I said earlier, the crust was apparently moving across over the mantle plume. What's actually happening is that this central object, as well as this one, are rotating. Okay? They're rotating. That means that when that rotates, this plume will move along with it. See how easy that was? So instead of this subducting and doing a bunch of weird crap they invented in the 1950s, we can ignore that. What's actually happening is that the central regions are moving faster than the outer regions. Okay? What that means is that the inertia of this central object is in a specific direction. For instance, the inertia of this specific object could be in this direction, while the crust and the outer regions still could have inertia going in, I'd say, right this direction. Alright? That means this has differential rotation in the outer regions, meaning wherever the mantle is, wherever the core is, and wherever the crust is, will always be different. This is the reason why the magnetic field of the Earth is different from its rotational axis by about, 23.5 degrees. The magnetic field is one place, the rotational axis is another. Or I guess the rotational axis would be right there because you have the seasons, and you have the magnetic field over there. Anyways, you get the point. In other words, plate tectonics was invented before they actually understood what's actually happening. Maybe their technology wasn't advanced enough to understand it. I'm not too sure. But basically, that's all it really amounts to. And the reason why I wanted to go over this, because there's another gentleman who thinks plate tectonics and mantle convection, more specifically, are also bogus. Okay? Mantle convection is the idea that you have convective currents. Okay? This is what you would call a convective current moving a plate this direction. And you have another convective current moving in this direction. Now the problem with that is it's a lithospheric plate. This top region is a lot less dense than the lower regions. So basically what you have here is oil and water. Whichever is lighter of the material is on top and will not subduct into the heavier material. That's a basic experiment you can do at home. Take some vegetable oil, put in a big container of water, maybe like a 2-liter bottle or a little Mountain Dew bottle, shake it up and see that the oil goes to the top. It doesn't subduct into the water. It separates because the oil is lighter. And being that you only have gravitational field pulling in all this up, pulling in the heavier, the lighter isn't going to go down there. Okay? It's not going to subduct. It's not going to go into the interior and cause large convective currents. There is no mantle convection. As we went over earlier in this talk, the only heat transportation mechanism that exists is inside of mantle plumes. You have plumes of material coming up that jut out, okay, and create chains of islands or whatever volcanic areas there are, like Iceland, and then you have Hawaii. That's how it actually works. But if you notice, the plume doesn't create a convective current, it just shoots up like a giant bubble in a lava lamp. Every now and then a giant bubble will come up, boom, shoot over here, dissipate, okay? That solidifies. And then have another lava lamp bubble come up here. Because you got to remember, the Earth isn't something that's like a lava lamp per se, where the bubble comes up within a few seconds. It takes many millions of years for this bubble to come up as it slowly moves through the outer mantle. But once it does, solidifies and dissipates the extra heat left over from core formation. And over time, all the mantle plumes will disappear and the crust will shrink a little bit more, allowing all that magma to exit in the form of volcanic eruptions and fissures. And then boom, before you know it, the crust will thicken. Okay? The crust will be very, very thick, and the planet will completely solidify and become a dead black dwarf star, like Venus or Mars. Basically, that really sums it up. For those future listeners, look up Herndon stuff. Marvin Herndon, actually, Marvin Herndon. He has a lot of good stuff on there. And Pratt actually has beef with the, let me go ahead and write these names out so you can see them clearly. I'll put this on the bottom of the page too. Yeah, J. Marvin Herndon. And you also have Pratt. Who? He has a very extensive paper on why he thinks plate tectonics is nonsense. And J. Marvin Herndon has his own whole Earth decompression model. I haven't really gotten too much in depth with that, but it is worth a look. Alright, today is April 9th, 2015. Hopefully people can understand what I'm talking about here.